In this video, we're going to talk about 4.4 Objective 1, where we solve right triangles. Let's go ahead and get started here with the angle B that's missing here. We're going to say that it's 90 minus 19.2 is going to be 70.8 degrees. And then our sides, if measured to the nearest tenth, should go to 3 significant digits. So let's go ahead and solve for B using tangent of 19.2 degrees is equal to 9.3 divided by B. So B is equal to 9.3 divided by tangent of 19.2. 3 divided by tangent of 19.2 is 26.7. And sine of 19.2 is equal to 9.3 divided by C. So C is equal to 9.3 divided by sine of 19.2. And this is going to be 28.3. All right, let's go on to the next problem here. And they don't fill in anything for us. They tell us that A is 20.3 degrees and C is 0.0809. And then we're going to use the table here to tell us how we should round. So let's go ahead and take this 20.3 and subtract from 90 to get angle B, which is going to be 69.7. And I'm going to use the sine of 20.3 and say that sine is A over opposite over hypotenuse, and hypotenuse was 0.0809. So A is equal to 0.0809 times the sine of 20.3. That means that A is, and we're dealing with to the nearest tenth here, so we're going to go to 3 significant digits, 0.0281. Because that first zero is not significant. Now we're going to have cosine of 20.3 is equal to B over 0.0809. And that means that B is equal to 0.0809 cosine of 20.3. 0.0809 cosine of 20.3 is, again, to 3 significant digits. B is approximately 0.0759, like so. All right. Angle B is given to us as 34.8 degrees. And 3490 minus 34.8 is going to give us 55.2 for angle A. And side C is 24.6. And that means that we're going to use sine of 34.8 that was given to us is equal to B over 24.6. So B equals 24.6 sine of 34.8. 24.6 sine of 34.8 is going to be to three significant figures, going to be about 14.0. And then cosine of 34.8 is equal to A over 24.6. So A is equal to 24.6 cosine of 34.8. And A is approximately 20.2. And B was about 14.0. C is 90 degrees, B is 61.5 degrees, side B is equal to 129, and 90 minus 61.5 is 28.5, and then tangent of 61.5 is equal to 129 over A. So A is equal to 129 divided by tangent of 61.5. A is approximately 70.0. And opposite over hypotenuse is going to be sine. So sine of 61.5 equals 129 over C. C is 129 over sine of 61.5. This is C is equal to, and then we're going to three significant figures. So it's about 147. B is 1.54. C is 4.09. Angle A, we don't have A or B, so we're going to have to use a inverse trig function here. We're going to have to say cosine of A is equal to 1.54 over 4.09. So A is equal to arc cosine 1.54 over 4.09. Second, cosine 1.54 divided by 4.09. We have three significant digits here for our sides. So we're going to have to go to the nearest 10th of a degree, is going to give us 67.9 degrees. And then sine of angle A is going to be 1. Sine of, we just solved for angle A. Solve for angle B. Sine of angle B is 1.54 over 4.09. So B is equal to the arc sine of 1.54 over 4.09. Arc sine of 1.54 divided by 4.09. We should get the complementary angle here, and we do 22.1. I just wanted to show you that it doesn't matter which one I find which way, but these two angles need to add together to give me 90 degrees. So I could have taken 90 degrees minus this angle to get this one, or 90 degrees minus B to get A. Now that we have our angles and our sides, let's go ahead. Let's just use the Pythagorean theorem because we were given two sides here. So a squared plus 1.54 squared is equal to 4.09 squared. And so a squared is equal to 4.09 squared minus 1.54 squared. And so a is equal to the square root of 4.09 squared minus 1.54 squared. Square root of 4.09 squared minus 1.54 squared. And we're going to go to three significant figures. It's going to be 3.79. Right? We're given this angle as 54.3 degrees. So 90 minus 54.3. We're going to find this angle up here to be 35.7. Then let's go ahead and find cosine of 54.3 degrees is equal to 125 over side P. So P is equal to 125 divided by cosine of 54.3. 125 divided by cosine of 54.3 will give me a P that is approximately, and we are using tenths of degrees, so three significant figures, 214. And then let's find n by using the tangent function. Tangent of 54.3 is equal to n over 125. So n is exactly equal to 125 tangent of 54.3. And so n is approximately, and then three significant figures, 74. A is 1.38 and B is 19.5. And we aren't given any angles other than the right angle here. Then let's find side C using the Pythagorean theorem. That second square root of A squared plus B squared is 19.5 as well. Okay. We'll leave it at that. That's 3 significant digits. So let's find angle A here is going to be given by tangent of angle A is equal to 1.38 divided by 19.5. So A is arctangent of 1.38 divided by 19.5. Going to go with nearest tenth is 4.0 degrees. That should leave me with 90 minus, 4.05. 3 significant digits. Yes. Okay. And 90 minus 4.05 is, again, we're going to go to 3 significant digits. So this is about 86.0. And there we go. All right. And the answer key only took this to 4.0. I don't know why when they say 3 for the nearest tenth, but oh, that's right. Because it is nearest tenth of a degree, 4.0 degrees, 86.0 degrees. Yes, nearest tenth of a degree. Okay. And solve the right triangle when A equals 49.1. C is 90. Use this table here, and we have enough information. No, I don't have enough information. I need another angle or I need another side. So there's not enough information to solve the triangle. A is 40.5 degrees. B is 49 0.5 degrees. Okay. And then that can give me some proportions to know all three angles, but I can't figure out the sides without at least one of the sides. So there's not enough information to solve that triangle either. Okay, that's it for this video. We'll come back next time and talk about 4.4 Objective 2. See you for the next video.